Okay, this is 1414, and we're given this situation where we have this pulley system, and we have blocks A and B. Block A weighs 60 pounds, block B 10 pounds, and we're given this angle like this. And we're trying to find the velocity of A, this block over here, after it moves down the plane 5 feet. So after it slides down 5 feet here, we're looking for the velocity of A. All right. So really we need to talk about how do these move in relation to each other so we can figure out the work for each. Um, so if we use this as our datum here, this pulley here, we can add up the total length of this cable. And the total length of that cable is, it would be 2SA, that's this length and this length, plus SB. So we have 2SA plus SB equals the total length here. So we can write this in a different way. 2 delta SA plus delta SB equals 0. That's the change in length, right? If SA changes by 1 inch, right, the change in SB is dictated by this equation here. Okay, so if we know that we're looking for SA is actually moves 5 feet, we know that this is 5 feet, and we can then solve for delta SB, and delta SB, if it's moving down, delta SB is actually negative, and it's negative 10 feet upwards. So it's moving upwards 10 feet if A moves down 5 feet down that plane. Okay, so let's figure out the work being done by both A and B. So we have the work of A, and remember that is just force times the distance traveled here. All right. So what is the force? Well, it's the force directed in the direction traveled, right? The 60 pounds is actually downward here. We're actually looking for the component of that in the horizontal direction. So to figure that out, right, we'll have this 60 pounds, but it's just a component of that. And the horizontal component of that is actually 3/5. So that's the component of the force, and then we still need to multiply it times the distance, which is 5 there. Okay, and that comes out to be 180 pound-feet. Okay, and then U of B, so the work of B. So the force is downward this direction, and the force is downward this direction, 10 pounds. So the force is actually directed opposite of the direction of movement. So we need to throw a negative sign out front here. Negative 10 times 10. So that is a negative 100 pound-feet. Okay, so we have the work from A to B, and so we can use our equation. Kinetic energy at state 1 plus the work being done from state 1 to state 2 equals the kinetic energy at 2. We know this starts from rest, so the kinetic energy at 1 is 0. And then we have our work being done, which we just figured out, which is 180 plus negative 100, or just minus 100. And that is equal to the kinetic energy at state 2. Well, that's 1/2 times the mass of A, right? And A has a total weight of 60 pounds. So that's 60 divided by 32.2 to get that into a mass. times the velocity of A squared. And then we have 1/2 plus 1/2, and now we're taking into account block B here, block B, and the mass is 10 divided by 32.2 VB squared. All right, so this equation has two unknowns in it, but if we go back up to when we solve for this here, we can also take a look at this equation, and we see that 2 VA plus VB equals 0. Okay, we have this equation as well. So, you know, we know that VB is equal to negative 2 VA. So we put in here negative 2 VA, and we come out with 80. 80 equals let's see, 80 equals 1.5528 VA squared, which then VA is equal to 7.18 feet per second. And that is the solution to 1414.